Imagine an object no larger than a city, an object so dense that a single teaspoon of its material would weigh billions of tons. An object capable of spinning hundreds of times every second while generating magnetic fields unlike anything found in our solar system. It sounds like science fiction, but these objects are real. We call them neutron stars. Today, neutron stars are considered some of the most extreme objects in the universe. Yet only a century ago, nobody knew whether such objects could even exist. They were nothing more than a bold theory. A strange idea born at the intersection of physics and astronomy. Today we know that millions of neutron stars may exist within our galaxy alone. But to understand how extraordinary they truly are, we first need to understand how they are born. Every star lives because of nuclear fusion taking place deep within its core. These reactions create the pressure needed to resist the star's own gravity. For millions and sometimes billions of years, these two forces remain in balance. But nothing lasts forever. When a massive star exhausts its nuclear fuel, gravity begins to win. The core starts collapsing under its own weight. Temperatures rise to incredible levels. Pressure becomes unimaginable. At a certain point, electrons are literally forced into protons. Neutrons are created. Matter enters an entirely new state. One of the most dramatic events in the universe begins to unfold. The outer layers of the star are blasted into space in a colossal supernova explosion. For a brief moment, the dying star can outshine billions of other stars. When the explosion is over, only its incredibly dense core remains, a neutron star. And this is where things become truly fascinating. A neutron star can contain more mass than our Sun. Yet all of that matter is compressed into a sphere only about 20 kilometers across. The density of a neutron star is so extreme that a single teaspoon of its material would weigh billions of tons. This makes neutron stars some of the densest objects in the universe. Their gravity is so powerful that it noticeably bends space and time around them. To better understand the scale of these objects, imagine the following. A neutron star could contain more mass than the Sun while occupying a region no larger than a major city. An enormous amount of matter packed into a space that a person could cross in just a few minutes by car. Gravity on the surface of a neutron star is so intense that a person weighing 80 kilograms on Earth would effectively weigh billions of tons there. Of course, no human could ever survive such conditions. Any matter approaching the star would be destroyed almost instantly. But even among neutron stars, there are truly remarkable examples. Objects so unusual that when they were first discovered, some scientists briefly considered the possibility of an artificial origin. These objects are known as pulsars, one of the most fascinating discoveries in modern astronomy. In 1967, astronomers detected a strange signal. It repeated with perfect precision, again and again and again. The signal was so regular that it seemed suspicious. Nature is rarely that precise. For a short time, some researchers even considered the possibility that the source might be artificial. But the truth turned out to be even more interesting. The source was not an alien civilization. It was a rapidly rotating neutron star. This was humanity's first encounter with a pulsar. A pulsar can be imagined as a giant cosmic lighthouse. Powerful beams of radiation emerge from its magnetic poles. As the star rotates, these beams sweep across space. If one of those beams periodically crosses Earth, we detect a pulse. That is why pulsars appear to blink at perfectly regular intervals. Some pulsars spin so rapidly that they complete hundreds of rotations every second. In the briefest moment, such a star can rotate around its axis many times. Their stability is so remarkable that some pulsars can rival atomic clocks in precision. In a sense, the universe has created its own perfect beacons. Some pulsars are so stable that astronomers use them to test the fundamental laws of physics. Observations of pulsars have helped confirm some of the predictions made by Einstein's theory of relativity. But there are true record holders among them. The fastest known pulsars spin more than 700 times every second. This means that parts of their surface move at a significant fraction of the speed of light. Yet, even that is not the limit. There are objects that appear extreme even when compared to pulsars. We call them magnetars, the most magnetic objects known in the universe. Earth's magnetic field protects us from the solar wind. The sun's magnetic field controls enormous eruptions of plasma. But the magnetic field of a magnetar exists on an entirely different scale. Its magnetic field is so powerful that it can influence the very properties of matter itself. Near a magnetar, physics becomes truly extreme. At times, the surface of a magnetar experiences enormous stress. These events are known as starquakes. They are among the most violent phenomena known in astrophysics. In just a fraction of a second, a magnetar can release as much energy as the sun emits over many months. These outbursts can be detected across vast distances of space. From time to time, magnetars produce explosions so powerful that they can be observed from tens of thousands of light years away. In only a few moments, they release more energy than humanity could generate throughout its entire history. Scientists believe these eruptions are caused by fractures in the magnetar's solid crust. In a way, they are cosmic earthquakes occurring under conditions far beyond anything found on Earth. Every such event reminds us just how extreme the universe can be. Even the most powerful natural disasters on our planet seem modest when compared with these cosmic explosions. Today, only a few dozen magnetars are known to exist. Yet even that small number has been enough to astonish astronomers. Neutron stars, pulsars, and magnetars reveal a side of the universe where ordinary intuition no longer works. A realm of incredible densities, unimaginable speeds, and magnetic fields far beyond anything humanity can create. They remind us that even after centuries of exploration, the cosmos remains filled with mysteries. Every new discovery seems to raise even more questions. Somewhere among the billions of stars, there may be even stranger objects waiting to be found. Objects that today exist only as theories, just as neutron stars once did. And if the history of science teaches us anything, it is this: the universe is almost always far more extraordinary than we imagine. Every time we think we are beginning to understand how the cosmos works, it presents us with another mystery. That is why the exploration of space never truly ends. Somewhere in the depths of our galaxy, pulsars continue to spin. Magnetars continue to erupt. The stars keep coming and going. Events that happened millions of years ago are only now reaching Earth in the form of light and radio waves. And humanity continues to look toward the stars, wondering what other incredible secrets are still hidden within this vast and endless universe.